We're going to pick up where we left off, where we configured motion control in our Compact Logix PLC using our Yamaha linear actuator. And if you notice on the side of ours, we've added a scale and a pointer. And we did this mainly that way that you could see what we're pointing at. And we could kind of tell some numbers. But notice our scale is off. 0 is down here and 300 is up here. And this one, 0 is here and 300 is down here. Now, I want to use this as an opportunity to talk about how we could scale our engineering units differently than our linear actuator units. Now, first of all, we could go do some configuration and change the scaling in the linear actuator, but I'm going to disagree with the thought of doing this because when we're troubleshooting, if I push this actuator all the way back, if I know that's 0 and I know all the way up here is 300, that's going to help me a lot troubleshooting. Now, when we get this thing mounted on a piece of equipment, our home point may be at 70 millimeters. That may be where we want 0 to be. At 150 may be 80. So let's talk through how we can do some scaling. And we are going to do our scaling in ladder logic. We did a whole video series on different ways to scale. The main reason I want to use ladder logic for this one is a lot of you are starting off, and the only programming language that comes with Studio 5000 Mini is ladder logic. So here's the LMC program that we finished up in the last video. And what I want to do is I want to create 2 new routines. So we're going to right-click main program, add new routine, and we're going to call this our motion. Then we'll right-click main program, add new routine, and we're going to call this our scaling. That way we have a separate place to do one and the other. Now, all the things that we did in the previous video really are our motion instructions. So we're going to Control A, right-click, and we are going to cut all those rungs out. And we're going to open up the motion, delete that rung that adds by default, and then right-click and paste. And all we've done is made a nice little folder organization for our linear AOI. And then we're going to go to our main routine and bring 2 new rungs down. And in those, in fact, let me show you an easy way you can do this. If we just highlight the rung number, we can type J, S, R, and press the Enter key. And that quickly will insert an instruction. And so JSR is a jump subroutine. I'm going to jump to the motion one, and then we'll bring another JSR in, and we will jump to our scaling. So all this is doing is giving us a little bit of folder organization. All right, now let's open up our scaling, and we are going to go to the Compute Math tab and bring down a CPT instruction. And our destination, we're going to type scaled position. I want this to have a decimal on it. And if I want a decimal, it needs to be a real number. So we're going to right-click scaled position, new, and here it says dent. We can either type REAL, real, or we can hit the dialog box and we can go down and grab the REAL real number. And that is how we'll have a decimal place. And then we need to talk about our expression. Now, I went through a lot of detail in the analog series. In fact, if you go up to the analog chapter in our Studio 5000 course, you'll see all of those of how we did in ladder, how we did in function block diagram, how we did in structured text. But long story short, we want to take the range of what we want to get out of this units-wise over the range of what we're putting in. Now, this is a really interesting scale, and that's why when I saw this, I was like, this is video worthy. Is notice on the range of what we're getting in, 0's down here, 300's up here. The range of what we want to get out, 0's up here, 300's down there. So this will be a really interesting one. So first we need to figure out exactly what those numbers are. I feel they're probably 0, but you know, I don't know how much attention I really took putting on this scale. So we need to go put a value of 300 in. Now, I had you add all this offline. And so for now, and this is only temporarily, for an expression, we're going to put 0 in. That way that scale position will be always 0. and we can download this program. So communications, who active, and it will open up. Your default trainer is 192, 168, 110. Hit the download button. And if you need any help downloading your program or configuring your drivers or any of that, then check down the description. We have a whole course on this, and hit that subscribe button because we put a video out every week. And then we'll click yes to put it into run mode. And we're going to need to do a few things. Just remember, we still have a few manual operations here. Mainly, we have to turn our servo on, and we need to do this in a little bit of a particular order until we finish up this program. I want you to switch 1 to the left position, and then we'll enable our servos. So right-click servo on, toggle bit. That will get our servos on. And now let's go look at our linear AOI. And so it's looking good, but we have a speed of 0 and a position of 0. Let's make our speed 100. And then we are going to want to make our position 300. That's the maximum of this linear actuator. And then we switch 1 to the right, and it's going to run up there. And yes, good, bad, whatever you want to call it, I did not put this scale at 0. If we look here, our 0 point is actually 27 millimeters. Now that's going to cause an issue on the other end unless I made this actuator go, oh, okay, it does go all the way down. So we're going to be okay. So 27 millimeters is going to be 1 point. Now we need to go figure out what the other point is. So let's go ahead and put 0 into our position. Then you probably could have guessed, but 327 millimeters is our other position. So that is the range of what we want to get out of this. The range of what we want to put in is 0 to 300, except the numbers are swapped. So we're going to have to work with that. But let's start writing out our equation. So let's go to the scale instruction and start a rung at it and open up our expression. And so first we need our linear AOI actual position. That's what actually has the millimeter value in it. So we'll open up linear AOI, and then we want to grab the actual position. Then we want to multiply it by the ratio of the range of what we want divided by what we have. Now notice I said range, and this is where it can get a little tricky. The range of what we want to get out of this is going to be 27 minus 327. Yes, those numbers are in the right direction. Now we're going to need some parentheses around those. Then we're going to divide it by the range of what we have. And just to make the format the same and so you can follow along with the previous videos, that would be 300 minus 0. Yes, I know 300 minus 0 is 0. Okay, then we need to add the low number back. And here's where it can get a little tricky is what are we adding back? We're adding 327 back to it. So plus 327. And we'll click off of that and hit the finalize button. And we are sitting at 0. And now it's showing 327 millimeters, which is what we want. Okay, now if we go to our motion instruction, we want to be able to put in 300 here and hopefully get 27 millimeters out over there. So I'm going to enter 300. And when we press the enter key, it goes up to the top. And if we go look at our scaling, now it is at 27 millimeters. So that same equation that we learned in the analog exercises works for pretty much anything. I'm not sure if we'll actually use that in this video series, but I thought that was a really quick segue to talk about how we could take the actuator position and convert it to some type of machine position. Next, let's talk about how we can do some basic pick and place programming. Click here for a playlist including it.